underscore or Kenya. Here I am sitting down with Francis Were Papa, who is an innovator and has been innovating with Chandaria Business Innovation and Incubation Center, and he's here to, of course, give us an insight on some of the vital projects that he has been able to conduct and have been approved, of course, by Kenyatta University and also the Chandaria Business. He's trying to answer some of the most important questions in physics, which have been puzzling almost every single physicist and also scientist across since the beginning of time, including the likes of Einstein. Of course, how does the apple fall from the tree and get to collide with Earth and the moon doesn't? So that is one of those questions that he's seeking to answer. And also, what causes the change in day and night? Francis Were, he's joining me now, and welcome to the show.
Thanks a lot.
Yes. How are you doing?
I'm Francis Were Papa.
Yes.
I'm innovator at the Chandaria Innovation Center, and I came up with the project in geophysics to explain what causes day and night and what causes an apple to fall until it collides with the Earth, but the moon cannot collide with the Earth.
Right. Of course, we also do see that in other planetary systems where they do have...
it is universal. These are universal laws.
All right.
Yeah, that is why we have universal constant. Yeah.
Okay, so these are two issues which you've been able to have a look at while you were there at the Chandaria
Innovation Center.
Okay.
Yeah, under the supervision of Dr. Ambuso, the geophysicist in Kenyatta University Physics Department. Yeah.
All right. So what led you to focus on these two specific kind of questions in physics?
First thing, these two questions, they need a new concept. That is why they have not been answered for a very long time. And this concept I came up because I innovated a theorem in mathematics called the theorem of sphere. I call it Papa's theorem of sphere.
Papa's theorem of sphere.
Yeah.
Okay.
Yeah, Pythagoras had a theorem, but it was about right angle triangle, but mine is for the sphere. Yeah, this theorem led me to come up with the law of gravitational field intensity, which is analogy of Gauss' law of electric field intensity.
Right.
So this general law of gravitational field intensity led me to derive the law that explains the rotation of the Earth on its own axis. That is, I can come up with the law that I can calculate the exact period of the Earth on its own axis and any body that rotates naturally on its own axis.
Right.
Yeah.
So I've heard you there mention Gauss' law.
Yeah.
Of course, some of those which have informed you to derive the equation, which you've just rightfully called the Papa's
theorem of sphere.
Right, Papa's theorem of sphere.
Yeah.
This is towards, as you said, explaining the rotation of a body on its own axis.
On its own axis, naturally. Yeah.
And this is going to answer the two questions.
It is going to answer the two questions. Yeah.
All right. Now take us through, of course, how that looks like.
Because I would like people to understand what this theorem of sphere is all about, because it is where my laws originate from. Yeah.
Let us.
Because if we can take, for example, for a sphere, on the sphere we have its volume and the surface area. When we consider the volume of the sphere, then we are considering the density. When you consider it is mass, the mass per unit volume is density. Then we have mass per unit surface area. That is what I call tonicity. So the ratio of tonicity to density is what gives me what is called the Papa's ratio. So from this Papa's ratio, then I can go ahead and find suppose the sphere is rotating on its own axis naturally. That is, when it is rotating like Earth, it is rotating on its own axis naturally. So it has centripetal acceleration, the acceleration towards the center, or the acceleration due to its period. And again, it has acceleration due to the weight of bodies on its surface.
Okay.
So we have two acceleration on the surface of the Earth. The acceleration due to its period, that is toward the center,
and also other bodies,
and acceleration due to the weight of bodies.
Okay.
So, and at the same time, we have the tonicity of this body. of the Earth. That is the mass per unit surface area of the Earth. So if you take the product of these two acceleration over the tonicity, that one gives us the acceleration product per unit tonicity. So acceleration product per unit tonicity together with the theorem of sphere, which I call that is the ratio between the tonicity and the density, I can derive the law of gravitational field intensity.
Okay.
And this law of gravitational field intensity, I can use it to calculate the gravitational field strength on Earth, on Moon, on Sun, on any body, whether small or big.
All right.
Yo.
So this is something that can be applied to every body which is rotating within its axis.
It is a universal law that I would like even, in fact, to present it to the world for them to test if it is a working principle on anything.
Okay.
Yeah.
Well, how exactly can we get to test this and also translate it to real life applications, maybe?
Because this one is easy, because it is the tonicity of the body multiplied by a universal gravitational constant that I came up with. That is 8.38 times 10 to the power of negative 10. Then it gives me the gravitational field strength on any body. It can be this cup, this table,
right.
It can be the Earth, the Sun, anybody. So it can give me the gravitational field strength. That is the law of gravitational field strength. Law of gravitational field strength.
Right.
Yeah.
Okay. So this is also, of course, answering that question on why exactly does the apple collide with the Earth and the Moon doesn't?
Yeah, why the apple collide the Earth and the Moon does not collide. Also, it can be derived from this law of gravitational field strength that I came up with. So when you derive, you will reach a point whereby, because this acceleration gravity per unit tonicity, that is the second notion in my theorem of sphere, this one distinguishes masses. We have masses that in nature naturally rotate on their own axis, and we have masses that do not rotate on their own axis. So this one can distinguish these two masses, because masses that rotate on their own axis, we call them gravitational masses, and masses that do not rotate on their own axis are called inertial masses.
Right.
So this collision, we have to distinguish the masses between these masses. We have the apple and the Earth. Apple does not rotate on its own axis,
so
but the Earth rotates on its own axis naturally.
And so does the Moon?
And the Moon also rotates on its own axis naturally.
Okay.
So you will find that a new principle comes up. We know the principle of equivalence. The principle of equivalence that was brought by Einstein, that gravitational mass and inertial mass are equivalent. So from there, I derived a principle of non-equivalence and a principle of equivalence.
Okay.
So when I derive these principles, they can explain to me why the apple and the Earth, they collide, but the Moon and the Earth, they don't collide.
All right.
Yeah.
So now we have also the question of diurnal changes. Of course, the change of day and night. How does that work out now?
You see, in the sphere, in the planetary sphere, we have the Earth or other planets revolving around the Sun, and this one gives us seasonal changes, or the coming of year from another year. And this was explained by Sir Isaac Newton and Johann Kepler. So Kepler's 3 laws of planetary motion and Newton's law of gravitation explains the seasonal changes, or why the Earth revolve around the Sun, or the coming of year and another year.
Right.
So at the end of the day, when you deduce, you will find that the revolution of planets around the Sun is due to gravity.
Okay.
Yeah.
So does Papa's ratio also apply in that?
Yes, it applies because also I deduce from my law the rotation of the Earth or any body on its own axis. So when I deduce from my law, my formulation, I get that I arrive at Newton's law of gravitation. So it tells me that the rotation of a body on its own axis is due to gravity.
Okay.
So you will find that bodies that are under the influence of gravitation, natural gravitation, like the pendulum, the rotation of the body on its own axis, that is diurnal changes, and the revolution around the sun, that is seasonal changes, all these motions obey a law called inverse square law.
Right.
And these motions are periodic. All these motions are periodic, and all these motions are natural. So you come up with the one law that governs all bodies that are under the influence of gravitation.
So have to be periodic and have to be natural.
Yeah, that all periodic motions that occur naturally is due to gravity. All of them obey inverse square law. Because gravity is a force of attraction.
Okay.
So when you want to locate any motion and you want to know if it is a law, it obeys the law of gravity, you have to go to that principle that all periodic motions that occur naturally, it has to be natural, obey inverse square law, because gravity is a force of attraction.
Of course.
Yeah.
All right. So this is all, of course, something that you've been able to do and also related to your own derivation, the Papa's law and the Papa's ratio.
Yeah.
And we've been able to do this in Chandaria's Innovation
Center.
So what kind of resources have been availed to you, maybe that you've been able to use towards this derivation? I
was subjected to those lecturers in the physics department. So they were my sparring partners. They were my sparring partners, the chairman and the Dr. Mbuso. So I researched and I found out more. In fact, when I came up with this research, I had not arrived at the quantization, time quantization. But after meditating and doing some more studies, when I was under these people, is when I arrived at the law of time quantization.
Okay.
That the time is particulate in nature.
All right.
It is not continuous. It is not calculus. Calculus means continuity.
Right.
And discrete means that it is in particulate nature.
Okay.
Yeah, in packets.
Okay.
Yeah.
So you've, the time quantization theory or
the time quantization principle comes this way. It is due to the fact that just the way we have leap years, after every 4 years we have a leap year. Also, with the hours, we have leap hours. For every 6 hours that you count, there is one leap hour. And one leap hour is 59 minutes. For every 6 hours you count, there is one leap hour. And one leap hour is 59 minutes.
Okay.
So, from the period of the Earth, that the Earth rotates 23 hours and 56 minutes, according to my calculations, when you use this model, you will find that when you construct a clock to describe this period of time, 23 hours and 56 minutes, you will find that the hour hand of our clock, the quantum clock or the new clock, is supposed to go anti-clockwise for 15 days and 15 nights, while the minute hand and the second hand, they go as usual. Okay. In that manner, you are going to measure exactly the rotation of the Earth on its own axis, which is the accurate and correct measurement of the period of the rotation of the Earth.
And this is something that we've been missing before.
Yeah.
All right.
So you will find that in 1 year, when you use this clock, it is going to have subtracted 1 whole day from the calendar, the Gregorian calendar we use. Because for this quantum calendar, in a leap year, it has 365 days.
Right.
But in normal year, is 364 days. So that the seasons do not come out of their place, we have to shift that I eliminated 31st December.
So I have to also
from the calendar.
Yes, I have to add it elsewhere.
Yeah, I eliminated because that one is irrelevant.
Okay.
1 day is irrelevant.
All right.
So the year in the quantum calendar ends by 30th December, and the first the 1st January begins on 31st December. In that way, the seasons are going to come in their correct order. So we'll have that the first season that normally comes 21st March is going to come on 20th March.
Okay. All right. So this is also part of that discrete model of time, rather than the calculus model, as you said.
Any change on the calendar, you have to change also even the seasons. Like the season that we have begun on 23rd September is supposed to begin on 22nd September. That is when the sun is going to be just exactly at the center.
Okay.
On 22nd.
Okay, so these are new laws, and maybe I can go through them again once more as you've mentioned them, and then we'll get more into how, of course, now we can translate this to real-life applications. As you've said, the law of gravitational field intensity, right, and also a principle governing all motions under the natural influence of gravitation. If I got that correct, right? And there are 3 laws which are governing the natural rotation of bodies.
Of a body on its own axis.
On their own axis, And there's the Papa's theorem of sphere.
Of course. Which is where I derive all my laws from.
Okay. And there's a principle of time quantization.
Time quantization, whereby for every 6 hours you count, there is one leap hour. One leap hour. And one leap hour is 59 minutes.
Right.
60 minutes.
All right. 59 minutes.
59 minutes.
I see. Of course. And then lastly, that discrete model of time.
The discrete model of time and the calculus model of time.
Okay.
So the model we are using now of time is the calculus model of time. It assumes that time is continuous.
Well, it's not.
But with the coming of quantum mechanics, actually nature is in particulate nature. The time is particulate.
In nature.
It is in packets. It is, and these packets, they are not of equal magnitude. We have some packets that have 60 minutes, and we have some packets that have 59 minutes.
So will it be correct to say time is just like light, because light is also
in particular nature.
Okay. All right. That is great. Now, how this being some of the new laws, as you've said, which have been now born in physics, what is your aim to get these laws now out there to everyone? How can we move that step?
Because this document, it has new laws, and it has almost 5 new laws that are supposed to be instituted in physics. And these are working principles. If you try to use them mathematically, you will find the results. They give the results. That is why they are above criticism, because it is about results.
So how do we prove them now?
We can prove them by comparing. Like that one of gravitational field intensity, you can compare with the Newton's results. My results are Newton's results, and then you can find out.
All right. So how do we do this need to be presented to a physics community, or is there a council of physicists that approves this?
Because this research originates from physicists, but it affects the public, the whole public, because the calendar and the clock, they affect everybody. So the results or the end product is for the public, but initially it begins professionally from physicists.
All right. What are the next steps that you are going to take now towards, of course, putting this out into the public for more people to get to know it?
Because I wanted these concepts to be adopted because they're above criticism. The physics department approved them. The chairman and the geophysicist who is there, they approved them because they are working principles. You can use your pen and paper and you can find the results that are there that you know. By using these new formulations.
Does this affect or go line in line with the quantum clock?
These ones go in line with the quantum clock, because when you are using quantum clock, you cannot use this old calendar. And with this old calendar, you cannot use new quantum clock. So every clock produces its own calendar. So this one, when it produces its own calendar, it has to eliminate 1 day from the calendar, by the end of the cycle. So this one, because it is going to give accurate measurement of time. Right now, the time we are measuring is not accurate, because suppose on your age, every year there is one day that is added for nothing on your age.
Right.
So if we use this new quantum clock, it's going to eliminate that irrelevant
all those,
day.
yes.
Yeah.
And discrepancies, of course.
And discrepancies.
All right.
Yeah.
That is Francis Were Papa, of course, has been there under the supervision and guidance of the Physics Department of Kenyatta University, and also the Chandaria Business Innovation and Incubation Center. Some of those things, of course, that the new laws which have been born in physics, trying to see how we can accurately measure time and also explain the rotation of bodies and give out laws which are governing the rotation of bodies on their own axis. And we're hoping that, or he is hoping that this can also be, it is a beyond criticism, as I said, has been proven, has been approved by some of the top physicists from Kenyatta University, and of course hoping that the scientific community is able to apply this in various working principles, and also trying to compare it with what we've had there before. Now, Francis Were Papa, before maybe we conclude, at this level, at this level of scientific discovery, are you going to now maybe concentrate specifically on this field, or are there other things you're also pursuing on the in the world of physics?
In the world of physics, right now, my concentration, I want this one to be published, to be instituted officially in physics as laws that can be learned and that can be applied, and actually contribute. It is a contribution to the stock of knowledge.
Right.
I would like it to be taken as officially laws that can be applied. So my appeal, because these documents, for them to be instituted, for it to be adopted, it can be adopted as a doctorate. So any university that can be interested in these laws, because they're applicable, it can grant me a doctorate for this document that I've researched for very many years, and it has been approved.
All right. That is great. Of course, anyone who's watching that should be able to take note of that. Is there a way that we can, or anyone who's out there can access this in a public portal, or do they have to come physically to KU to get to read some of the work that, or some of that discovery you've made?
Because right now I'm at the Chandaria Innovation Center, and I have this document, and I'm looking forward to how I can publish it to the world, these laws. In fact, looking for maybe somebody who can volunteer and assist me to publish
put it on a
laws,
repository, of course.
So that they can be viewed, or they can be they can reach all learned scholars, and they can go through them.
All right. That is Francis Were Papa, of course, very focused in matters of physics and also science, and how we can apply that to the calendar, the counting of time, and also to also measure the rotation of bodies on their axis. Some of those laws, he said, you can get to see them once they come to publication. So if you are a university or someone in the field of academia, science, and physics, ensure you're reaching out to Francis Were Papa. He'll be there at the Chandaria Innovation Hub at Kenyatta University if you want to have a discourse on matters of physics. Anything else that I might left before we go for that short break, Papa?
I just wish you the best of luck, and I would like the world to take this document seriously, because I have another project about resuscitative preservative called Principia that I discovered or I innovated, and I'm working on it. It's patented at Kenya Industrial Property Institute. This resuscitative preservative is there because the world right now is not recognizing the anaerobic existence of a person. That is, somebody cannot die immediately. You die after 72 hours. That is when the coordination between the brain and the body now ceases.
Okay.
And in that process, very many people are killed in hospital because of the methanol or the formaldehyde, because it is poisonous. It preserves, but it is poisonous to the cells. So it normally destroys the anaerobic existence. So very many people are killed in hospital because our preservatives are poisonous. But sphere preservative is not poisonous. It preserves by making the microbes to be dormant. And at the same time, it is a heart reactivator. When it is introduced into the system, it makes the heartbeat to increase. By that way, we can use it to resuscitate people who normally die because of asphyxia when they are training in the ground, in the field. We can resuscitate people who drown after a short time. They are taken out of the water. We can resuscitate people who die of malaria. That immediately kills them. People who die because of immediate issues, they can be resuscitated due to
using this preservative. Of course, we'll get some time in the future to invite you again to talk about it, the Principia Preservative. But thank you very much for having us get an insight in some of the new laws which you've come up with, of course.